Let's talk about section 10.3. Now, section 10.3 is still going to talk about hypothesis testing for our population means. However, this time we're going to concentrate more on what happens when I don't know the population standard deviation, which is very often what happens. Okay, so understand that we are actually going to run these tests, and we're going to focus on just this one very special one for this section. Just like we did in previous sections, we concentrated on one type. So the first thing that we have to understand is that pretty much anytime we do a hypothesis test, no matter what type of hypothesis test we have, all our possible samples of any given size have an equal opportunity to be chosen. It's super random here, okay? The thing I do know is that the population standard deviation, that is unknown, and that's very important to make MARDIV right now, is that if you do not know that population standard deviation, this is going to tell me what type of testing I need to do, okay? Now, the other thing is that in order for me to be able to do this test and kind of work my magic, is that our sample size is got to be at least a size of 30 or more, or the population came from something that was approximately normal, which is, this is right here, guys, this is basically our central limit theorem, meaning that we can apply it so it's going to be a normal size shape otherwise, unless they told us it was already normal to begin with. Now, because I do not know the population standard deviation, so because of this part right here, that's very important to make note of, like that's the part, because of this, as long as this condition and this condition are met, it can be either a Z or a T. Now, because the fact that this is unknown, this is what tells me that we are now in a student T distribution. Okay, now with student T distributions, if you are going to do this by hand, please understand to get your test statistic, it's going to use the formula of X bar minus the mean divided by the sample standard deviation divided by the square root of n. Okay, again, X bar being our sample mean, mu is going to be the presumed value of the population mean. That's going to come from that null hypothesis. S stands for our sample standard deviation, and N stands for our sample size. Now, because we are using T values, do remind yourself that in order to get your critical value of your T, you are going to need to know what your degrees of freedom are, so we can get our test statistic itself. Okay, so recall a couple of things that we've done previously is that there's the type of hypothesis test you're running and the level of significance. Now remember, to determine the type of test, you are simply just going to look at the symbol that's contained in the alternative hypothesis. Now you're going to recall that that alternative hypothesis is telling me, is it a left tail, a right tail, or a two-tail test? So that's what I mean by determine the type of hypothesis test. Now, once you've determined what type of hypothesis test and you know your level of significance, you're going to basically kind of draw out a reject region. So the decision rule for the reject region is that we reject the null if the test statistic calculated from the sample falls within this reject region. Now, we are going to look at how to construct the reject regions for each of the three types of hypothesis testing using a student T. Now, the basic rules for all of those that we did for the normal distribution are pretty much the same, except for instead of finding a critical Z score, we're finding a critical T score here. So once you've done that, please understand that to get your T scores, we do have to basically, if you're ruling by the T score only, so you have two ways to figure out your rejection regions. You can either use a p-value or you can use your T values. Either way, if you're going to use the T value, so the test statistic against a critical value, you are going to have your test statistic. So remember, T by itself is the test statistic. If it is less than or equal to a negative T alpha, which is the critical value for a left tail test, then we will reject. If my T is greater than or equal to my T alpha for a right tail test, we reject. And if it's a two tail test, whether it's positive or negative, that absolute value of that item has to be greater than or equal to my T alpha over 2. Okay, so what this is doing is basically we will have to use the table to do our figuring out our critical value. Again, my critical value is going to be coming from that alpha. Now, if you don't want to use a table, do remember that those of y'all that have a TI-84 calculator, you are more than welcome to actually use your calculator to find this. But for those that have like a TI-83, I'm sorry, you're going to have to use the table unless you run a full hypothesis test. Okay, so this table that contains the critical values for your t-distribution for certain numbers of your degrees of freedom, remind yourself that basically we normally call our level of significance alpha. That will be found in the problem itself. Now, typically when we talk about alpha and that level of significance, that's going to come across our critical t-score. This is basically our cutoff region for our rejection. Now it'll be either T alpha or T alpha over 2. Again, first find the value of alpha and determine from the top column what part of the table you use. Okay. Look for your alpha under an area and one-tail for a one-tail test, and alpha for a value of alpha under the area in a two-tail test for two tails. Okay, do understand that when we simply scan through the value, you will find the cells where the degrees of freedom row lines up with the column that intersects that alpha. Again, do note that for your two-tail test, the value obtained from the chart is actually T alpha over 2, so keep that in mind. So let's take a peek at this, and again, I'm going to show you how to do it with the calculator, and I'm going to show you how to do it with the chart. So find the critical t-score that corresponds with 14 degrees of freedom at the 0.025 level of significance for a right tail hypothesis test. Now, if you are going to be doing the table, do understand that basically you're going to scan through the table, look for the row that has 14 degrees of freedom, and the column that's a one-tail. It's a one-tail because they told us it was a right tail, so we know that's a one-tail there, with an area of 0.025. And where do they intersect? And that's hence going to be that alpha. Again, remind yourself that because it is a right tail, okay, so this is my t's here, this would be 0. Because it's a right tail, this is going to be my T alpha. It's not divided by 2 because it's a one tail only. And that basically this area underneath here, this area is alpha. Okay. Now, in your table, the nice part about the table is the table always gives the area to the right. So in our case here, when we look at the table, again, I knew it was a one tail. This was the area of the one tail. This was my degrees of freedom. Where do they cross? And this will be my T value, my test statistic, or sorry, critical T value that I need. Okay. If you're going to be using the calculator instead, then we may have a little bit more thinking involved. There's a little trick to this that we do have to worry about. Okay, so let me remind you of what we need to worry about with the calculator. So if you're using the table, it's just laid straight out here. If you're using your calculator, remember it's going to be second vars number 4. Now, please understand here that if I type in my area under the thing and then go into my degrees of freedom, this will spit back out a negative number. The calculator is always determined on a left area only, and I was not looking at a left area, I was looking at a right area. So either remind yourself that basically it's this number but positive because it's on the right side, or when you do your second vars number 4, you'll need to type in 1 minus your alpha. And again, I highly recommend this 1 minus alpha if you're doing anything that is a right tail. And paste it in and you're good, and that will always give your positive version. T values we do round to 3 decimal places, so keep that in mind. Okay, and all that is telling me is that if I were to draw out my chart, okay, so if I were to draw out my nice lovely area here, and again, here's 0, this area, that area is alpha, okay? But this right here, this T alpha, this is that 2.145. And again, we know it's the positive version because it was a right tail, okay? And this area under the curve is that alpha that we talked about, which is the 0.025. Okay, let's put this all together with an actual problem. So I'm going to walk you through this problem, and we're going to do this one by hand. So this is if you were not using your calculator to help you. And then I'm going to show you how to use the calculator to help you. So nurses in the large teaching hospital have complained for many years that they are overworked and understaffed, and the census among the nursing staff is that the mean number of patients per nurse each shift is at least 8. So 8 or more. Now the hospital administrations, they claim that the mean is actually lower than 8. Now in order to prove their point, so the hospital administration is going to prove their point to the nursing staff, the administration gathers information from a simple random sample of 19 nurses' shifts, and the sample mean is 7.5 patients per nurse with a standard deviation of 1.1 patients per nurse. Okay, now we are going to use the test administrators. They're going to use their claim using an alpha of 0.025, and we're going to assume that the number of patients is actually normally distributed. So the first thing we always want to do is we want to state our null and alternative hypothesis, just like what we did in previous chapters. So who is researching? Who's the person making the claim? Well, the administration staff is. So in this scenario, the researchers are the hospital administration. They're the ones who had to gather the evidence. They're the ones that are making the claim. And their claim is that the mean is actually less than 8. Now, that is your research hypothesis, or also known as your alternative hypothesis. Now, to write that mathematically, you're just going to use the mu symbol for mean and say less than 8. And again, the logical opposite of a less than is a greater than or equal to. Now I'm specifically going to put a greater than or equal to on here because this one in particular, as we were reading the problem, they used the words that it was at least 8. So because they use the word at least 8, this is why I know it's going to be greater than or equal to 8. If I don't have like any other direction of telling me it's more or less, I'm just going to say an equal to sign here. Now, once you've done all that, now you've stated your hypothesis. Now you got to figure out what type of test you're going to run. Now, again, the biggest part that you had to remember is that, did you know the population standard deviation? If you do not know the population standard deviation, that gives it away that we're still running all of this talking about the claim is on a population mean. So since the claim is on a population mean and I don't know the population standard deviation, but I do know the sample, we're going to run a t-test. Now, in order to run the t-test, I do need to kind of make note of my level of significance, which was the alpha that they gave me. And again, I'm making note of that because I'm going to need that to find my, I'm going to need that to get my critical t-value there. So we're going to gather the evidence and we're going to find our test statistic. Our test statistics always comes from the x bar minus the mean divided by the sample standard deviation divided by the square root of n. And that's going to give us approximately a negative 1.981. Now, the second part is that now that you've got your test statistic, you do need to make note of what was the critical t-value, okay? Now, the critical t-value is going to come from your alpha. It's going to come from your degrees of freedom, as well as, is this a left or a right tail? Now, in our case here, remind yourself that this was a left tail test. And again, how I knew it was a left tail test was as I was working through this problem, remind yourself that we said that the alternative hypothesis was the mean was less than 8. And again, that right there, because this was a less than 8, that tells me that it's a left tail test. Okay? So because it is a left-tailed test, we know that critical t-score has to be negative. You can again look at your calculator to get this, or you can use the table to get it. That's going to be fine. Okay. And now basically we have to figure out, do we keep the null hypothesis? So basically fail to reject it, or do we reject it? Now, the rejection region, I'm going to show a graph in a second to show it, but because the test statistic when we calculated it, okay, so the test statistic, and that's the part that a lot of people are forgetting, you have two different values. You have your test statistic, okay, in our case here, we're using a t. This came from that x bar minus the mean all over s divided by the square root of n. And then you have your critical, okay, and critical t-value. And this came from basically the chart or the calculator, however you wanted to do that. You're using these to compare, okay? This one here, the critical t-value, this creates the reject zone. That is actually what this does. This tells me whether or not it falls in the reject zone. Now, in our case here, it does not fall in the reject zone, so we say that we're going to fail to reject the null. So let me show you a chart so you can see. Again, here's 0. Here's the negative t alpha. And again, this was that negative 2.101. And then the sample that we ran, that t-value, that test statistic, notice that it is actually just slightly bigger than our critical one. And because of that, that does not fall in the reject zone. So we say we fail to reject. So we can interpret this conclusion to mean that the evidence collected is actually not strong enough at a 0.025 level of significance to reject the null hypothesis, okay, in favor of the administration's claim, meaning that we do have to kind of go with what the nurses are claiming. Now, let's talk about p-values. So for the t-distribution table in the back of the book, it cannot actually be used to calculate p-values. That is only to calculate t-values. Now, in the same way that we do the normal distribution tables, those actually calculated p-values. So these are slightly different. If you are looking for your t-values, please understand that to get an exact p-value, you're going to need to turn to technology. So guys, you're going to want your calculator or statistical software. In our case here, we're going to use the calculators. So once you have your p-value, we can also still do the whole, where is our reject zone? So instead of our reject zone being with a test statistic and our critical value, we can now use the p-value, okay? So this is very important, and if you have not written this down, okay, you need to keep this down somewhere, because this is what we are going to refer to back over and over and over again. So is that p-value bigger or smaller than my alpha? If the p-value is smaller than or equal to my alpha, that means we've fallen in the reject zone, so we're going to say reject it. If the p-value is bigger than the alpha, that means that we're in the fail to reject area. Okay, so let's start this off. A locally owned independent department store has chosen its marketing strategies for many years under the assumption that the mean amount shoppers spend is no more than $100. Now, a newly hired store manager claims that the current mean is higher and wants to actually change the marketing scheme accordingly. Now, a group of 27 shoppers is chosen at random. They have found that random sample has been found, those shoppers have been found to spend a mean of $104.93 with a standard deviation of $9.07. Now, we're going to assume that the population distribution of the amount spent is approximately normal, and we're going to test the store manager's claim at a 0.05 level of significance. Now, nowhere in here is this actually worded as a question, so Keyword here is we are going to test the store manager's claim. That right away told me that, hey, you're running a hypothesis test. And since you're running a hypothesis test, we're going to have to use technology for this to kind of help us out. So I'm going to use the technology to help me run through it faster. However, even though we're using technology, that doesn't actually stop the way we perform our hypothesis test. The first thing you got to do is state your null and alternative hypothesis. So in the problem, we read that the store managers claimed that the mean amounts was more than $100, which basically means that as we write that mathematically, that the mu was greater than 100. And ladies and gentlemen, that right there is going to be my alternative hypothesis. Now, since the manager was looking for evidence to support that claim, that is actually your research hypothesis. That's the alternative. Now, the logical opposite of that claim is going to be that the mean is less than or equal to 100. And again, that was kind of said that it was shoppers spend at most $100. So at most or no more than 100 means 100 or less. And that's where that symbol comes in. If I am not given anything to really tell me what the symbol actually is, we just use an equal to sign for just the base idea there. Now, once you've determined the null and alternative hypothesis, we do have to determine what type of test statistic this is, as well as state the level of significance. Now, guys, step 2, this is what changes every single section. Now, in this section, we're going to concentrate on the student t-distribution, but remember in the previous section of 10.2 that we had to run the z one, okay? And again, how do I know which one it is? Do you know the population standard deviation? If you do not, we know we're going with a t, and again, we're going to make note that our alpha was a 0.05. Okay, now once we've done that, we're going to actually gather up the evidence. We're going to use our TI 83 or 84 calculators to help us out. So let's start by just writing down the important information that we read as we were running through the information there. We are going to, just like I said, write down a few little key things. Now, they told us what X bar was. They told us our sample standard deviation. They told us our N, as well as remind yourself that the mean was 100. That came from, you had the null and the alternative hypothesis that we found. Now remember, the alternative hypothesis was saying that our mean was more than 100, and our null was saying that our mean was less than or equal to 100. Okay, so once you have all that information down, the next thing you're going to do is you're going to hit the stat button, scroll all the way over to test, and again, we chose that this time we're running the t-test. So hit the t-test, and we're going to plug in all that sample statistics that we were given. We're choosing stats instead of data because we didn't put anything in the list, okay? So again, only choose data. So only actually choose the data if you plug stuff in the list. Now in our case here, we didn't plug anything into the list, so we're just going to go with it. Okay, so these are the two types of calculator screens you're going to get. I'm going to show you again, kind of walking you through the steps, but I have the calculator screens up here if you want to pause and try to run it yourself. So calculators popped up on screen so you can kind of see where I'm hitting all these buttons. So I'm going to hit clear. Oh, I just really like starting with a clean screen. It's not necessary, but I do find it really helpful here. So stat, arrow all the way over to test, and number 2, t-test. Again, enter to execute here. So again, I'm choosing stats. Again, if it's highlighted with data here, you'll see that data is highlighted. All you have to do is arrow over, click the stats, and enter. Scroll down. We're going to type in our 100. We're going to type in our 104.93, our 9.07, 27, and then these here are going to match with the alternative hypothesis. Now, the alternative hypothesis on this one says that we wanted to know if that mean was more than 100. So again, more than was that symbol there, which is why it takes a time and really awesome if you'll actually write it down and then click calculate. And that's all you're going to do. Now, again, I am going to make note of that information. So I'm going to come back to the screen here so you can see it a bit bigger. what I really want to make note of, and this is a part that a lot of students forget to write down, is I want to make note of these items, okay? Especially this and this. Now, why do I want to make note of those two? One is the test statistic, okay? So instead of actually having to do, and just a reminder here, this here basically was the test statistic. It does the x bar minus the mean all over s divided by the square root of n. It does all that for you in the calculator and spits back out that answer. Okay, so if you want to check it by hand, you can pause, check it. However, it also does the p-value. And again, remember that p-value is basically the probability that this test statistic will happen. Okay, so you have your output screen, which was shown on that right there. And again, using that test, I am going to make note of that p-value. That is really critical to have. And we're going to basically just remind ourselves that we're looking at the p-value versus our alpha. Now remind yourself, if the alpha is bigger or equal to, we reject. If your p-value is greater than your alpha, then you fail to reject. Now, I understand the word reject shows up more than once, so think of it as basically you're either guilty or not guilty. We never say, like when you go through the court system, if you're guilty or innocent. We say you're guilty or not guilty. So there's either enough evidence to say you're guilty, so we're going to reject the null, that's our guilty, or there's just not enough evidence to say that you're guilty, and so that's where we fail to reject. Again, I can't say that you're innocent because maybe you are actually guilty, but I just don't have enough evidence to prove you're guilty. And that's why we use this kind of reject or fail to reject, because you're not saying that that you are completely 100% accepting what's being said. It's just you just didn't prove that they were guilty. You didn't prove that there was enough evidence to reject. Now, in our case here, our p-value was approximately 0.0045. Our alpha was 0.05. And that right there should kind of give you an idea that the alpha was bigger in this case here. And so since the alpha was bigger, we're going to reject the null hypothesis. This basically means that at a level of a 0.05 level of significance, there is enough evidence to support the manager's claim that the mean or average amount of spent by each customer is actually more than $100, which means maybe they do need to look at different type of shopping strategies. Let's try this again. So the meat packing department of a large grocery store packs ground beef in 2-pound portions. Supervisors are concerned that the machine is no longer packing the beef to the required specifications. Now, to test the claim that the mean weight of the ground beef proportions is not 2 pounds, the supervisor calculates the mean weight for the simple random sample of 20 packages, and that sample mean was 2.1 pounds, and the standard deviation of that sample was 0.33 pounds. Now, is there sufficient enough evidence at a 0.01 level of significance to show that the machine is not working properly? We're going to assume that the weights are normally distributed. Okay, so again, the first thing I'm going to do, state my null and alternative hypothesis. Now, in our case here, the supervisor wishes to investigate. So again, these are that, what do you want to know? What is being claimed? What is somebody believing or thinking? This is where I'm kind of gearing into finding that hypothesis. So the supervisor wishes to investigate whether the machinery is not working, and they say that basically the mean weight is not 2 pounds. Again, I'm not specifying if it's more or less, it's just not 2 pounds. So we're going to say that the mean is not equal to 2, and the logical opposite of that is just going to be equal to 2. So we have our 2 hypotheses there. And again, I'm going to remind myself is now I have to determine what type of testing I'm going to run. So I ask myself the question, Do you have the population standard deviation? If my answer is no, we go to a t-test. Okay, I do want to make note somewhere down there what my level of significance was. Now, once we have that figured out, we're going to have to put stuff in the calculator. So before we put stuff in the calculator, let's write down our main information that we need to plug in, which is X bar, our sample standard deviation, our sample size, as well as what was the mean equal to in the null hypothesis. Once I have all that information, I'm going to hit stat, arrow over to test, choose number 2 from that test, the t-test, and then we're going to choose whether we had stats or data. And again, this case here, we have stats. Okay, so I'm going to show you the calculator screens now, but I'm going to also pop up the calculator and show you me entering it in. Okay, so this was the last test we ran, so all I'm going to do is just hit clear, and I'm run stat, arrow over to test, number 2, and then I'm going to type in all my information here. Now, stats is already selected, which is nice, so I'm just going to type in 2, then I've got 2.1, and notice after every single time I'm entering this in, all I'm doing is hitting enter, and it's moving down to the next level. Okay, once you get to the part where you have to choose the alternative hypothesis, again, just highlight the one that is the correct one, so it's blinking over the correct one, and then hit enter, and it will highlight it fully, and if you move down, you'll see that it stays as a black box around the highlighted area, and then click calculate. Now, can you click the draw button? 100%, yes, totally click the draw button if you feel like it, but I'm going to tell you something. Guys, that is it. It's pretty much kind of useless other than just drawing a picture. I mean, the big main things, all I want is the T and the P, and I don't know about you guys, but those are really small. So I find it easier to not even look at the drawing area. I find it easier just to say calculate and give me the data. So stat, arrow over to test, number 2, and again, all this stuff, I've already just entered it in, so it's going to stay the same there. And I'm just going to click calculate, and then there we have it. So again, I find this one easier to read, especially those of y'all that have a TI-83. It's just easier to run the calculate option than it is to actually have it draw it. Okay, so again, what do I need to make note of? What are the things that I really want to pay close attention to on that spit out, which is T and P. Okay, I'm really going to concentrate on the p-value. The p-value, I'm going to compare that to the alpha that I have. Okay. But again, remember that the t that it outputs is actually the test statistic. The p-value is the probability that that test statistic happens. Now we have to actually draw the conclusion. And this is where take note of what the p-value was and what your alpha was. So in our case here, the p-value given by the calculator was 0.1912. Our level of significance that we were asking about, our alpha, was 0.01. So in our case here, our p-value, since it is bigger than our alpha, we're not in the reject zone. So we say fail to reject the null. And basically we interpret this conclusion to mean that the evidence collected is not strong enough. So there's not enough evidence at a 1% level of significance to say that the machine is working improperly. Okay, guys, remember we spent a lot of time in chapter 8 learning about the confidence intervals. This is basically, we're testing to see, like, do we fall in this confidence interval based upon, is it more or less? We're kind of making that case of, if this probability, this test statistic that I have, the probability that this test statistic happens, is it just far enough away from the actual population mean to be true enough that this could be not what they were claiming originally, and the alternative, the research claim, is true? Or is there just not enough evidence to say that I'm far enough away that this was not just a random fluke?